In this video, I'm going to build a little bit on what we talked about in the last part of the video. There's something called the empirical rule, and it's also called the 68, 95, 99.7% rule. And this says that in a normal distribution, in any normal distribution, 68% of population members fall between -1 and +1 z-scores. 95% fall between -2 and +2, those two z-scores, and 99.7% fall between -3 and +3, which means almost the entire population is between -3 and +3. In a normal distribution, anyone below -3 and anyone above +3 is very extreme. And let me give you one real-life example of this empirical rule. So one real-life example involves z-scores. It turns out that it's known that in the general population, IQ scores have a mean of 100, a standard deviation of 15, and a normal distribution. So that tells us that in the general population, 68% of population members are between 85 and 115, because if you start at 100 and you go down by 15 and you go up by 15, you get to the z-scores of -1 and +1. Also, in the general population, 95% of population members are between 70 and 130, because if you start at 100 and you go down by 15 and down by 15 again, you get to -2. And if you go up by 15 and up by 15 again, you get to +2. And also in the general population, 99.7%, or almost the entire world, almost the entire general population, is between 55 and 145, because those two numbers have z-scores of -3 and +3. So if you start at 100 and you go down by 15, down by 15, and down by 15 again, you get to -3. And if you start at 100 and you go up by 15, up by 15, and up by 15 again, you get to +3. So if you've been wondering if you've been wondering in what situation would a z-score ever be useful in real life, this is a good example of when it is useful. So z-scores help us. Well, z-scores are useful